everybody. Here is a second example of finding component form and magnitude of a vector, since in class today we had about 5 minutes. So I want to refresh your memory, and let's take a look at this vector. Vector v has an initial point of 1, 11 and a terminal point of 9, 3. And what we want to start with is actually the component form. So I'm going to take my fancy V-shaped brackets here, and what I want to do is I want to calculate the horizontal change and the vertical change. And remember, today we talked about it being easier to assume the initial point had the x1 and y1 values, and the terminal point has the x2 and y2 values. So what I'm going to do is just plug in 9 minus 1, 3 minus 11. And what I end up with in my component form is a horizontal component of 8 and a vertical component of negative 8. So that's it. And I think it's better if I show you a picture of what this looks like. So if I were to sketch this vector, our initial point is 1, 11. Who's decided on 11? That's way too big to be sketching. And our next point is 9, 3. 9, 3. And so if I were to draw this vector, remember I start at the initial point, and my arrowhead is right before the terminal point. So what I'm really trying to find here in the component form is how this vector is changing. So if I look at 8, that means the horizontal change. And if I look at my vector, it definitely looks like it goes over 8, and then it goes down 8. And there's my vertical. So you can see these show up in the picture. Now if I want to find the size, or the length, or the magnitude of this vector, I'm going to go back to the formula, the distance formula that we talked about in class. So x2 minus x1 squared plus y2 minus y1 squared. But if you really think about this, we already did x2 minus x1 when we found the component form. And we already did y2 minus y1 when we did the component form. And I am just not interested in doing extra work. It's hard enough to get to school. It's 5 degrees outside on a good day. So I'm just going to look at x2 minus x1. We already know that that's 8 squared. And I know y2 minus y1 is negative 8 squared, which gives me the square root of 64 plus 64, or 128. Boom. If you want to be half of a pre-calc student, you would stop there. But if you want to be 100%, you're going to think about how we simplified radicals today. I'm taking you back to Algebra 2. So many of you decided a factor tree was the best way, and I'm just going to break it down. 64 and 2, 8 and 8. But I'm going to stop here because I have a pair of numbers. So another way I could write square root of 128 is 8 times 8 times 2. And I know 8 times 8 is really 64, and if I take the square root of 64, it's 8. I can't pair 2 with anything, and I can't take the square root of it cleanly, so I'm going to leave it as 8 square root of 2, 100%.